Okay, this is Math 21C, quiz number 8. Okay, the first problem asks us to find the partial derivative of the function g with respect to each variable. G is a function of r, theta, and z, equal to r times cosine of theta plus theta times z. Now the partial of g with respect to r, which you may have seen written as g sub r, or partial of g with respect to r, is just going to be, we take the derivative of r, keeping theta and z constant. So now theta, any function of theta, z, any function of z, those are all just numbers. They're a constant number. So we take derivatives of them as we do derivatives of constants. So now if we're taking the derivative with respect to r, the only function of r here is r cosine theta, and cosine of theta is just a constant. So when we have, c times x and we take the derivative with respect to x, we just end up with c. So just like that, here we're just going to end up with the constant that's in front of r, that's cosine of theta. Now notice theta times z, that's just a constant, so that goes away. So the partial of g with respect to r is cosine of theta. The partial of g with respect to theta, so here we have r, that's constant, times cosine of theta, a function of theta. The derivative of cosine of theta is negative sine of theta. So this is negative r sine theta. Now z times theta, z is just a constant, so when we take the derivative with respect to theta, we just get z. So the partial of g with respect to theta, is negative r sine theta plus z. The partial of g with respect to z, well here r cosine theta is just a constant, so when we take the derivative that goes to 0. And then when we take the derivative of theta times z with respect to z, we just get the constant theta. Okay, so this is g sub z. Okay, the second problem asks us to find the derivative of the function f at this point, negative 1, 1 in the direction u equals 3/5 I minus 4/5 j, where the function f of xy is equal to x plus y squared. Now, the directional derivative is the gradient of f evaluated at the point, dotted with our unit directional vector. So the first thing we need to find is the gradient. The gradient is the partial of f with respect to x times the I direction, plus the partial of f with respect to y in the j direction. So the partial of f with respect to x, y is now a constant, so we just have 1, right? The derivative of x with respect to x is just 1, plus the derivative of a constant with respect to x is 0, so we just have 1 times the I direction. So that's where we get our I. The partial of f with respect to y, so here x is just a constant, so the derivative of that is 0. The derivative of y squared with respect to y is 2y, so we get 2y in the j direction, 2yj. Okay, now we want to evaluate this at our specific point, P0. P0 is negative 1, 1, so when we plug in negative 1 for x, there's no x's in here, so it changes nothing. When we plug in 1 for y, here we had 2y, so now we just have 2 times j. So our gradient at our point is I plus 2j. Now we have to dot this with our unit directional vector, but before we can do that, we have to make sure that our directional vector is a unit vector. The way that I do that is I look at the unit vector, the directional vector u over magnitude of u. The magnitude of u is going to be the square root of 3/5 squared, which is 9/25, plus negative 4/5 squared, which is 16/25. So we get u, which is 3/5 I minus 4/5 j over the square root of 9/25 plus 16/25. Now the square root of 9/25 plus 16/25, 9 plus 16 is 25, so this is 25 over 25. The square root of 1 is just 1. So this is a unit vector. It stays the same. It's just 3/5 I minus 4/5 j. Now to find the directional derivative, we dot our gradient at our point with our directional vector. We get 1, right, that's the coefficient on I, 2, that's our gradient evaluated at our point, dotted with our vector u, which is 3/5 negative 4/5. So 1 times 3/5 plus 2 times negative 4/5 is 3/5 minus 8/5, which is negative 5/5 or negative 1. So our answer is negative 1. The third problem asks us to use the chain rule to find the partial of w with respect to v when u equals -1 and v equals 2, where w is a function of x, y, and z. W is xy plus natural log of z. X is a function of v and u, it's v squared over u. Y is a function of u and v, it's u plus v. And z is just a function of u, it's the cosine of u. So when we draw our diagram, here's w. W is a function of x, y, and z. Now x is a function of both v and u. Y is a function of both v and u. And z is just a function of u. So now to find the partial of w with respect to v, we have to find all of the paths that take us from w to v. Namely, we can go through x, so we can go w to x, x to v, or we can go w to y, y to v. Notice we can't go w to z, z to v. There's no, z is not a function of v. Okay, so we're going to do the partial of w with respect to x times the partial of x with respect to v plus the partial of w with respect to y times the partial of y with respect to v. Okay, the partial of w with respect to x, the only function of x here is x times y. This natural log of z, that's a constant, that goes away. Y is a constant, so constant times x, when we take the derivative with respect to x, we just get y. So y times the partial of x with respect to v. Okay, this 1 over u here on x is just going to stay there. It's a constant. But v squared is a function of v, so when we take the derivative with respect to v, we get 2v. So our partial with respect to x, our partial of x with respect to v is 2v over u. Our partial of w with respect to y, same thing here, natural log of z just goes away. X times y, here x is constant, constant times y, the derivative with respect to y is just that constant, so it's x. Okay, so here's our x. Now the partial of y with respect to v, u is a constant, so that goes away. V, the derivative of v with respect to v is just 1. Okay, so we end up with y times 2v over u plus x times 1. Now we want this to be in terms of u and v, since we're taking the partial with respect to v. We want things to be in terms of this layer. So now y is u plus v, so we plug that in for y. We keep our 2v over u, that's still in terms of v and u. X is v squared over u, so the whole thing we get is u plus v times 2v over u plus v squared over u. So when we multiply that out, we're going to get 2v plus 2v squared over u plus v squared over u, which ends up being 2v plus 3v squared over u. Now the last thing to do is we want to evaluate when u equals -1 and v equals 2. Right? That's what they told us in the problem. So we're going to evaluate what we just found out, that the partial of w with respect to v is 2v plus 3v squared over u when u equals -1 and v equals 2. So we plug in 2 for v and we get 2 times 2 plus we plug in 2 for v and -1 for u and we get 3 times 2 squared over -1. So we multiply that out, we get 4 minus 12, which is -8. So our answer is -8.